Hey guys, so in this video I'm going over Unit 6 review. So I'm going to do a few of each kind and I'm going to allow you to pause the video and attempt it yourself. So for number 1 as a review, we're going to identify which sides we have or which sides we're given, meaning which side is the opposite, adjacent, and hypotenuse. If you want to identify all of them, you can. Always across from the 90-degree angle or the little box is your hypotenuse. According to the angle identified, the side across from it, from the angle that is not touching the angle indicated, is your opposite side. And then the last side, or the side that is touching the angle indicated but is not the hypotenuse, is your adjacent side. So once we've identified our opposite, hypotenuse, and our adjacent side, we can identify which sides are actually involved in the problem. So in number 1, there is nothing on our hypotenuse. Yes, there is a hypotenuse, but we don't care about how long it is or the value of it. So we're only worried about the adjacent and the opposite side. So in our SOHCAHTOA saying, so some old hippie caught another hippie tripping on asphalt, and we break it up every 3 letters. Which one has an A and an O involved? Hopefully you can see the last one. Well, the last one is tangent of x, or the angle measurement, equals O comes first, so O is on top over A. So in number 1, we're going to be using tangent. We have tangent of our angle measurement, well, in this case it's theta, we are not given the actual measurement, equals our opposite side is 14 over our adjacent side, which is 15. And then we're going to solve this for theta. So we want to get theta by itself. Well, to get rid of this tangent, we have to do the inverse of tangent. Let me get off of this gray. Hold up. So we're going to take the inverse tangent of this whole side to get rid of the tangent. And we end up with just theta. And what we do on one side, we always have to do to the other. That equal sign, it means that we're going to have to keep both sides equal to each other. Meaning we have to be fair. If we do something on one side, we got to do to the other. So we have the inverse tangent of 14 over 15. Then we're going to go to our calculator and find what this value is for theta. So let's see if I still have it up. Since I am on my iPad, I am going to go ahead and do it on Desmos. If you have a graphing calculator and you need help, I already did a video on YouTube to help you with your graphing calculator. If you need more help, just let me know and I can help you out with that. So in Desmos, we always want to make sure we're in degree mode. So I went to the settings button in the top right corner, hit degrees, and now I'm in the correct mode. I don't know, this was doing it earlier. Let's see if I can fix this. Okay, so what we want to put in our calculator is inverse tangent. So go to functions. Inverse tangent is right there. And we've got 14 over 15, or 14 divided by 15. So we get 43.025, so on and so forth. We're told in our packet to round to the nearest tenth. So we got 43.0 degrees. And that is our answer. So if you will, pause the video and attempt number 2 and number 3. Number 2, you should have gotten 46.2 degrees. Number 3, you should have gotten 37.6 degrees. Now let's look at number 4. Number 4, you see that we are given the angle measurement, but we're not given one of our sides. So let's see how that changes things. So we can identify our sides first. The side across from the 90-degree angle is always our hypotenuse. The angle indicated is going to tell us the other sides. So the side across from the angle indicated is our opposite side. And the side that is touching the angle but is not the hypotenuse is the adjacent side. So the only two that are involved in this problem, or that we're given anything about, is our hypotenuse and our opposite side. So in our SOHCAHTOA, which one involves an H and an O? Hopefully you can see it's the middle one, which is cosine. So cosine of x equals A over H. So in this case we have cosine. Remember, x is representing our angle measurement. In this case we do have an angle measurement instead of just a variable. Equals, oh, my bad. I am so sorry, guys. Give me 1 second. So we did not have adjacent and hypotenuse sides. We had our opposite and our hypotenuse side. So we are dealing with our sine, not our cosine. So sine of the angle measurement is opposite over hypotenuse. So sine of the angle measurement, we still have the angle measurement equals opposite side is 10. Hypotenuse is x. To get x by itself, we've got to move the x to the other side to get rid of the fraction first. Then we can get x by itself. So if you know the trick, you can use the trick at the moment. If not, you have to do it the long ways. So multiply by x, we get x times sine of 51 degrees equals 10. Divide by sine of 51. Divide by sine of 51. Sine of 51's cancel out. Left with x equals 10 over sine of 51. And we're going to go into our calculator and type this in. So you can go into another box in Desmos, or you can just exit out of it. But we have 10 divided by sine of 51. And we get 12.86759, so on and so forth. Rounding to the nearest tenth, we get 12.9. So that would be our answer for number 4. If you will, pause the video and attempt 5 and 6 now. For number 5, you should have gotten 16.4. If you need to, pause the video and look through my work if you need it. Number 6, you should have gotten 4.0. Moving on. For 7, 8, and 9, we are dealing with the word problems. So in 7, a boy flying a kite lets out 300 feet of string. So I'm going to draw a picture to represent what is going on. So we've got the grass, we've got the string, and we've got a kite at the end of the string. And no, it doesn't have to be perfect. So we're told that the string that's let out is 300. The kite has an angle of elevation with the ground at 38 degrees. So from the ground to the string, or the line that's cutting those parallel lines, is 38 degrees. And we're asked how high above the ground is the kite. from the kite. Given that 90 degrees, we can assume it's 90 degrees. And we want to know this distance. So for the people that do not like drawing these pictures, as long as your triangle ends up having a 90 degree, having one of the angles being 38, and as long as your hypotenuse is 300 and your opposite side is x, it does not matter. So you could have drawn the picture like this with 38, 300, and x over here. You could have drawn the triangle like this, where this would have been 38, this would have been 300, and this would have been x. Does not matter how your triangle ends up, as long as it's the same essential features. So again, the key features in your triangle should have been, it's a 90 degree angle, or a right triangle, my bad. Your hypotenuse should have been 300. Another angle should have been 38 degrees. And the side opposite of your 38 degrees should be x. If it is the same, then you should get the same answer. I'm going to use the first one I drew. So the angle indicated is going to tell me what kind of sides I have. So I have my opposite side, and I have my hypotenuse. So I'm going to be dealing with my sine trig function. So I can substitute in the information I'm given. So sine of 38 equals, my opposite is x, over my hypotenuse, which is 300. So to get x by itself, I have to multiply by 300 on both sides. 300s cancel out. I'm left with x equals 300 times sine of 38. I'm going to put this into my calculator to get x. I have 300 times sine of 38, and I get 184.69, so on and so forth. I'm going to round it to the nearest tenth like we did for 1 through 6. I'm going to put 184.7. And that would be my answer for number 7. If you will, pause the video and attempt number 8 and number 9 now. Number 8, you should have gotten 24.4. If you need to pause the video to check my work, please do so, or look at your work. Number 9, you should have gotten 12.5. And there is the work to show you how. Don't worry about the 2 triangles that were at the bottom of this page. They didn't have enough information for you to do anything with it anyways. All right, number 10. Number 10 through 15 is our special right triangles. So let's do one of each. So 10, we're given 30 degrees and a 90 degrees. So we can assume the third angle is our 60 degree angle. And what I've told you in lesson, I think 5 and 6, is that with your special right triangles, if you have an x given to you, change it to z every single time. It will help you not confuse it with the ratios of the sides. So for the smallest side is across or opposite from the smallest angle, is always small leg. It's always your x. Your other leg, across from your next smallest angle, long leg, and this is your x times the square root of 3. And then your hypotenuse is always 2x. Those are your ratios of your special right triangle 30, 60, 90. So the one that is given is our long leg, because we're told that the whole long leg is equal to 10. So we're going to start there because then we can find what x is. So we're going to do 10 equals x times the square root of 3. To get x by itself, we have to divide by the square root of 3. We're left with 10 times the square root of, or 10 divided by the square root of 3. Hopefully some of you remembered that we cannot have the square root in the denominator, so we have to rationalize it. To rationalize it, whatever is in that square root, we have to multiply it in the numerator and denominator. So in the numerator we get 10 times the square root of 3. In the denominator we get just 3. So this is our x. So in our small leg, that means x equals 10 times the square root of 3 over 3. That means for the hypotenuse, x is 10 times the square root of 3 over 3. So what this means, we can just put it into the calculator to keep it simplest radical form. This would be 2 over 1 times 10 times the square root of 3 over 3. So that would be 20 times the square root of 3 over 1 times 3 is just 3. So that would be our hypotenuse. So z side would be 20 times the square root of 3 over 3. And then our y side is our small leg, which is our 10 times the square root of 3 over 3. And that would be our answer for number 10. So let's go through a few more examples. If you will, pause the video and attempt number 11 and 12 now. Number 11, you should have gotten z is 6 times the square root of 3, and y side should be 6. Number 12, n should have been 2 times the square root of 3, and m should have been 4. So if you need to pause the video, if I'm going too fast, please do so you can look at my work. Now we're moving on to another special right triangle, 45, 45, 90 degree triangles. So we're given 90 degrees and 45 degree angles so far, so we can assume the other one is 45 degrees. If you don't believe me, all 3 angles in a triangle have to add up to be 180 degrees. So we would have 90 degrees plus 45 degrees, which equals 135. And then we would do 180, subtract 135, which would give us 45, which would give us that last angle that I just put down. So we're going to identify our different sides and our ratios. So we have a leg of the right triangle, another leg of the right triangle, and these are going to be our x's. And then our hypotenuse is represented by x times the square root of 2. So we're just given our hypotenuse, so we're going to take our hypotenuse value and set it equal to the ratio and find x. So to get x by itself, divide by the square root of 2, divide by the square root of 2. The square root of 2 divided by the square root of 2 gets canceled out on both sides. And we end up with x equals 7. So that means x equals 7 on the B leg and x equals 7 on the leg A. So we get 7 and 7 for B and A. So if you will, pause the video and attempt number 14 and number 15 at this time. 14 should have gotten m as 2 times square root of 2 and n as 2. Number 15, you should have gotten z and y as 2. Alright, and then the last one I'm going to do with you, number 16. So there is no special angle given. There's only a 90-degree angle. That's given. So we just know that this is a right triangle. So we know our hypotenuse and we know both legs. So we're going to use our theorem to find the missing side. So our a squared plus b squared equals c squared. Our legs are our a and our b, so it does not matter which one you substitute in for which letter. We can do x first, or we could have done 8 first. Squared. But our c is always our hypotenuse. And then we're going to simplify this. So we get x squared plus 64 equals 256. Subtract 64 on both sides. X squared equals 192. To get x by itself, we got to square root it. And in the directions, it does say leave your answer in the simplest radical form. So we have to simplify this radical. So we're going to factor out 192. So we got 2 times 96. 2 times 48, 2 times 24, 2 times 12, 2 times 6, and 2 times 3. So those are prime factors of 192. We're going to put all of these numbers underneath a radical. So we've got 6 2's, 1, 2, 3, 4, 5, 6, and 1 3. And because our imaginary index is 2, hopefully you will know that, we're looking for pairs of the same numbers to move out of the house. They are the same, they get married, they move out of the house and become 1. So 2 2's get married, move out of the house, and become 1 2. Another pair of 2's get married, move out of the house, and become just 1 2. And lastly, the last group, another 2. So we have a 3 left over underneath the radical, and we can simplify the outside of the radical by multiplying. So 2 times 2 is 4, times 2 is 8. So our answer for 16 is 8 times the square root of 3. And that is your answer for 16. For 17 and 18, if you will, pause the video and attempt it now. 17, you should have gotten 2 times the square root of 38. And 18, you should have gotten x is 4. If you guys have any other questions or concerns, please do not hesitate to let me know. Thanks, guys.